When a Docker container finishes doing its job, it exits, and with that, all of the data inside the container disappears. If a Docker container fails for some reason, such as the host machine running out of memory and crashing, then you'll lose all of your data inside the container. Because of this, it sometimes makes sense to store data outside of the container itself. In another case, you would want data to be shared across containers. For example, if you have a container that runs a database, you could scale it up horizontally by adding more containers, which all connect to the same storage. In cases like this, you could use Docker volumes. Docker volumes are persistent storage shared between the host machine and the Docker containers, and they allow you to attach external storage to a container and potentially to share the same storage across many containers. The data in a Docker volume persists outside of the lifecycle of a container. So if, for example, you had a data collection system which ran in a container once per week, you could create a Docker volume to store the files which it saves, and they would still be there the next week, even though the container is stopping and starting. Because you're intentionally saving your files into the Docker volume, everything in the volume is going to persist even after the container exits. Docker volumes are created by Docker, either using the command line or when you specify a new one to attach to a container. A Docker volume is a lot like any other folder on your machine. In fact, you can find the contents of a Docker volume in your file system if you really look for it, but their contents are not intended to be manipulated by anything other than Docker processes. So they aren't stored in the most accessible places. So as is inevitably the case, I can't teach you everything, so it's important to know how to use the docs to find out how to use Docker volumes for yourself. So let's practice using them to look up how to work with Docker volumes. You can see that to create a Docker volume, you simply run docker volume create followed by So here's the usage with these optional options and optional volume, and down here you can see those different options available, and here's an example. So you can see that to create a Docker volume, you simply run docker volume create followed by the name of your volume. And then the docs show that I can attach a volume to a container when I run it like this. The -v flag is for volume, and the argument to the -v flag is a mapping between the volume name, which I just created, and the path inside the container which this will be mapped to. So now whenever the container tries to use something in the /world directory, that's actually going to be found inside the hello volume, which is storage outside of the container. We can also look up the main Docker volumes ref to see all of the details. It shows a bunch of stuff, including that you can attach a volume to a container when you run it using the --volume or --mount, as well as the -v flag, which all roughly do the same thing, although you can look at the details there. And you can also see all of the command line options for Docker volume by running Docker volume without anything after, no subcommands, and that'll show you the different commands which you can use from there. So I can run docker run create, docker run inspect, docker run ls, prune, or remove. So if I want to see the details of a Docker volume, I can run docker volume inspect, followed by the name. Looking at the docs, we can see how to delete a volume once we're done with it as well. Although it's not recommended to mount file paths which are not Docker volumes to a container, you can do it, and we call that a bind mount. It's done in exactly the same way as with a Docker volume. You just specify an absolute file path rather than a Docker volume name. Because the file path needs to be absolute, a handy trick here is to use the pwd environment variable, which evaluates to my current directory in the absolute file path. So when I ran that container, every time it looked inside this directory for something, it would actually find it inside this path on the host machine. A common mistake is trying to use a relative path, something like this. Unless the argument is an absolute path, Docker assumes that you're referring to the name of a volume. And if that volume doesn't exist, then it creates a volume with that name. So if I run this, then that container isn't actually mapping the directory next to me to the location inside. Instead, it's created a blank volume with that name. A good use of a bind mount is when you want to make changes to a file which a container uses and see the effect without having to stop and start the container over between each change. Whenever the container looks for the file, it looks in the mounted location and uses whatever's there. So why would you use a Docker volume over a bind mount? Well, bind mounts are dependent on the host OS. If you run the same command on another machine, it might not have that file system location to mount to, specifically if it's a Windows machine versus a Linux machine, for example. And this would mean that the Docker container is not totally independent and not self-contained. As such, it's not portable, which is one of the key benefits of Docker itself. Volumes also have other advantages and features over bind mounts. They can be pre-populated by a container as they're created. They can be easily encrypted. They can be easily stored on a cloud storage service like S3, and they're also more performant. And aside from that, they work in nearly the same way.